What's up, everybody? Welcome to Light Source Engraving. I'm your host Patrick, as usual, and today I have a fun unboxing for you. I bought the cheapest laser, 5 watt or above, on TEMU. This thing came in at about $96 shipped. No air assist, no honeycomb, no extras, just a gantry and a laser. So let's put it together, give it a few tests, and see how it does. I would like to thank you for popping in to check out this video. Thank you to my patrons and channel members for your support. I do appreciate it. Don't forget to like and subscribe, all that good stuff. Now let's just go unbox this beast. Today I will be using my special, just regular Leatherman unboxing knife today. Didn't want to get too fancy. I wanted to keep it about the same as the actual laser itself. Well, if I can get cut through that. Come on, tape. There we go. All right, here we go. We have the user manual for the 5 watt high performance 400 by 400 blue laser engraving machine. Well, it just has some color and some pictures and some settings. Well, that's way more than what I expected. Now, I would like to see where this QR code takes us, so we'll check that out in a bit. We have some cork for practice material, some safety glasses. We have a power supply, a tools box. Has a little cover for the laser module, piece of acrylic, screws, some other tools, some other engraving samples, some desiccants. Here's our 5 watt laser module. All right, we have gantry pieces. Here we have our control board, which would be our front gantry, part of the gantry. The rear, here's our X, USB cable. Okay guys, I scanned that QR code that was on the front of the owner's manual, and it actually takes you to the iWeColor YouTube page, which has directions for assembly. You can see that right there. So that is nice that they actually have an assembly video. Way more than I expected from cheap laser. This does remind me a little bit of the original Ortor LaserMaster and how it's put together and how the belts run on the rails, and then the gears turn and moves the whole gantry. But we'll be able to see that in just a moment when I start putting this together. So they are claiming a 0.06 millimeter spot for this 5 watt laser, that the controller is compatible with lightburn, and in the owner's manual here we have a list of products, highlights, and then we get into our first steps. So I will use the tools provided with the toolbox. I believe there were tools in there. I was wondering, this is indeed magnetic, so it will just clip on the end of the laser module, just like that. The different screws are in different bags. A little brush, some zip ties, wrench and 2 hex keys. It even has a USB drive with tutorial videos on it. We'll have to check that out. Then a piece of wood and an aluminum business card in the toolbox. First, we will need the front of the gantry. It does have this big sticker right here. I'm assuming that this is going to need to come off, otherwise your vents won't serve much of a purpose. So I'm just going to go ahead and pull this off just because it's bothering me. Okay, and our first step will be to attach the gantry rail. So we have this little piece of belt that's stuck through there. We need to stick through. There, the little piece of belt is sticking through the slot. Then we can shove this all the way in and tighten it down with our M5 screw. All right, now we'll do the same thing to the other side. The hardest part is trying to get this piece of belt. Now I'm going to put the piece of belt through the slot, hopefully. All right, finally got that through. There's the belt. Just need a screw. All right, now we have both in there. Let's get them both, get these tightened up a little more. All right, now we need to put the X gantry on the frame.
And the next trick after we get the gantry on the frame is we have to push the belt backward so that it forms. What I do is I just hold it with my finger down right behind that closest wheel and then push the belt until it forms a little loop up in between the two wheels. Then I can grab that loop and pull the belt through. The belt then needs to go around the gear and then down and under the furthest wheel. Then once you get that started under the wheel, then you can start to pull it tight and just let the belt rest in the track of the rail. Now I move on to the other side, and again I'm going to hold the belt with my finger, or no, this time I'm going to use my hex wrench and then push that belt through and then just reach in with the driver and pull that belt up and then around the gear, then back down through the center of the two wheels and then underneath the wheel that's kind of being blocked. So at this point you can see that I get that belt to finally go underneath that wheel, and once you get it through, then you just have to pull it tight, let it rest in the center of the track, and at this point we're ready to attach the left and right rails to the back rail. And at this point we put the nut into the channel on the extrusion and then tighten the bolt down, and we'll use this to adjust the tension on our belts. And we'll do that to both sides and then attach the left and right rails to the back of the gantry. So here you just need to run that belt through that top slot where the belt is supposed to go, and it can be difficult to feed that through. Took a few tries. Finally got it. Then once that piece of belt is through the slot, then we can insert our screw and start tightening the back of the gantry onto the two side pieces. Now it's time to mount the laser module on to the carriage, and it just has a slot that the little nut tightens down into. And what I found is that the eccentric nut was loose, so I had to tighten that up. And despite the eccentric nut being tightened up, it still has a forward lean to it. So it does have a cant, it does not sit level. So here I'm going to tighten that eccentric nut up to get rid of the wobble and get it just tight enough that it still slides freely and there's no wobble. And the cant is still there, but it's not wobbling. Now we have the simple task of plugging in the power cable to the Y stepper motor, then another cable plugs into the X stepper motor, and then a cable plugs into the laser. Now we just need to manually add the device to lightburn. So I'm just going to hit create manually, add a Gerbil device. It's going to connect via USB, change the name of it, and then type in the dimensions. Once we have the dimensions set, click next. This machine does not have limit switches, so I'll just set the origin at the front left, and I will untick the home on startup box. Now I just have to select the proper COM port to get it communicating with lightburn. And once that happens, we'll just do a frame and make sure that everything is communicating properly. I'm just going to frame that circle. And now that the circle's framed, I'll just go ahead and add some settings to the line just so we can make sure it's running properly. So it's just going to run fast with a 0% power just to make sure it's moving around smoothly. And then I'm going to change it to not use absolute coordinates and use the center of the job origin. All right, now we're just going to run a little job here and see how it does, making sure that the laser is indeed working. I did find that the focal distance is 2 millimeters below the bottom of that guard that's at the bottom of the laser, the little magnetic piece with the laser plastic on it. So here we're just running an offset fill on that circle just to test it out and make sure everything's working. All right, here we have the offset fill, and it looks like it is starting to work. I increased the power a little bit there so you can actually see a mark, got it in focus, and it's working. Now I'm just going to have it run a circle. I made the circle a symmetrical circle instead of the oval that I did have, just so I can make sure that it does draw a symmetrical circle. And so far, so good. And at this point, I wanted you to see how much of an angle that carriage is setting at. I decided to mess with the eccentric nut a little bit more to see if I could loosen it or tighten it to get rid of some of that angle. And overall, it didn't work. There is a little bit of play within the attachment at the attachment point itself for the laser module, but not enough to totally correct it. So a little bit later, I'll look into the actual X gantry piece itself and see if I can rotate it to help take care of that angle. And at this point, I ran a line at 3,000 millimeters per second and ran it just to do the outline of my logo, make sure everything was looking good. And after this was done, it looked okay, but I could still see some jitter in some of the lines. So I looked into that later on and found that I couldn't fix the jitter. So I'll show you that in a little bit. Now what I'm going to run is the filled version of the logo. So we'll let that run and take a look at that when it's finished. Now I did have this graphic set up to run a line after the fill. The fill looked pretty good. The line looked inconsistent in some places. I could go back and look at the settings and see exactly what caused that, but I wasn't worried enough about it, and then I forgot about it. So I did try to cut this out. I ran one pass and then ran a second pass, and the second pass did cut it out. I just don't like cutting when there's no air assist, so I try to avoid cutting at this point. And I think the reason I got those darker marks is I was just running too much power with as slow as it was going for the line, but that's just material testing. And here you're going to see a series of circles and a series of squares just to test how well this thing is making lines. And as you can see, there is some jitter. The lines are not smooth. So in order to address that, I thought, let me go back and check all 3 eccentric nuts. And I did adjust those. The 2 on the Y gantry did need adjusted to tighten the carriage down a little bit. But that did not fix the problem, as you'll see in the second test that'll be coming up. And here's a good example. You can see the jitter. The lines are not totally straight. There is some up and down waviness to the lines on the square and the lines on the circle. So I'm not too happy with the performance right out of the box as it sets. So I'm going to have to investigate what's causing that jitter. But the next example, I will have adjusted the eccentric nuts, got everything nice and snug so nothing's moving around. And let's take a look at those results here in a moment. All right, now let's take a look after the adjustments. See if we notice any improvement. I don't really see improvement. Still see some jitter. And this was running faster at 6,000, and there's still jitter there. So I'm not getting nice, clean lines. And what I did find is that the carriage, even with the eccentric nut tightened down, it still has a little bit of wobble to it. So that's just probably going to be with the design of this laser. This is about the best it's going to get. And here's the first version of that logo that I ran. And you can see how bad the wobbliness is in those lines. They're not straight. The curves are not smooth. So after tightening everything down and getting it just the best I could get with tightening things, let's run it again and see how it compares. As I was watching this through the camera, I noticed that it might have been a little bit improved, but it's definitely not fixed. And I forgot to turn off the cut, so I just stopped that during the middle of the cut. But here you can see that there is still some wobbliness to those lines. They are not smooth. The curves are not smooth. As the camera focuses, it might be a little better, it might be a little worse. Just depends on where at in the graphic you're looking. But overall, not impressive. And here I decided to do a photo. I just picked some random settings and ran it. This is at 10,000 speed, so it's obviously moving much faster. But overall, it turned out pretty good for guessing at the settings. Here's a little closer look. And not bad. I'll show you in a little bit. I decided to run it a second time and increase the LPI, but overall the details came out. You could definitely tell that it's a car and the clouds in the background. And here I want to get you a close-up of the control board. You can see that there's the X and the Y, and it does have a spot for a second Y. There's a 12 volt and 5 volt power port. And you'll see X and then Y1, Y2. There's a probe and a couple CNC ports there. So it looks like your standard generic CNC/laser control board. Are some additional ports at the top. But overall, pretty simple board, pretty standard design. All right, folks, I do want to show you, I did run one more photo And I just guessed at these settings, so there's no magic to it. Just took a guess, but I ran this one at a higher DPI than the bottom one. And overall, not too bad just for guessing at settings with this $96 laser. Now, I do have this strapped down so it doesn't move, but here you can see how much of a cant there is on this laser module. Hold on. When I was talking about how this is canted forward, like you can really see it. All right, and here's where you can see that the laser module is canted forward in relationship to the gantry. And the carriage kind of sits that way, and it just needs, I really think this eccentric nut needs to be a little shorter, and that would end up making this twist a little bit and line up. So if that eccentric nut wasn't so thick, I think that would do a much better job of straightening it up. But it is what it is. I'm not going to put a ton of time into it. It's a $96 laser. I just wanted to get it and see how it would do. Overall, it seems sturdy enough. It's just sheet metal on these front and back rails, and you got to see that on the, you can see that with a close-up view of the control board. But would I recommend it for a laser? No, absolutely not. Now, if you were interested in cannibalizing parts from this, like I am, it's probably worth the money, because you get several rail pieces, you get wheels, eccentric nuts, get some gears, even get a control board, which piecing this stuff together, you'd be hard pressed to get everything for that amount of money. And even have some nice stepper motor cables that are in the mesh wire loom. But overall, for what you get for the price, it is pretty impressive. You could definitely make a few tweaks to it. You could always add an air assist. It doesn't come with a honeycomb, so I had to add that to it. So by the time you start nickel and diming yourself, yeah, you'd be better off just getting an all-in-one that comes with everything. But fun little starter project. And again, I don't like cutting with lasers that don't like air assist, so I wouldn't use this to cut with. And I could already see problems with cuts just for the couple of test cuts I did. It started to burn, and just wasn't comfortable with it, so I didn't let those cuts run. But yeah, that's it. There's an in-depth view of a $96 laser in 2024. So I hope y'all enjoyed this video. It's taken me forever to make it. I've been a little under the weather, so I think it's taken like 5 days to finally get this thing done. 5 separate days, not 5 consecutive days. But yeah, so please like, subscribe, and share. I hope you enjoyed it. I hope you stick around on the channel for the next videos that I have coming out. I have some good ones that I think everybody will like, including more with Lone Star adhesive, more with the Rotoboss Talon, and all kinds of other stuff. So stay tuned, and most importantly, everyone, have a great day, and I'll see you in the next one.